So right now, most of you are Android developers or Android users, and in your hand, you have these powerful tools for debugging Android apps. The same things that you're using, My Taxi, Google Maps, taking pictures. This same device has so much other power for building mobile applications. And so that's what I will talk about today. Who am I? My name is Andrea Falcone. Maybe if you saw me in the program and you're Italian, you think, Andrea Falcone, who's this man? That's not me. Very American. And I've had this confusion several times while I'm here, so I prove to you this is me. I'm a software engineer. I work at Google, and where I work on Firebase or on Crashlytics. Are you familiar with Crashlytics for crash reporting? Maybe hands, some. Good. And Firebase, we had the booth. I think I saw all of you, gave you T-shirts and things. So I've been working on Crashlytics for almost 6 years. And I've been through 2 acquisitions. We were acquired by Twitter in 2013. And I built Fabric and Beta by Crashlytics with the team. And in January of 2017, we were acquired by Google, where we joined the Firebase team. So I've been with the team for a long time and continue to build the product. In my time here, I've worked on the Android SDK, so the mobile library that you use, the Beta by Crashlytics Android app, and all sorts of tools for mobile developers. Gradle plugin, Android Studio plugin. I've also worked on Fastlane, if you're familiar with that. It's an open source tool for release automation for Android and for iOS. So I've worked on a lot of tools. And through my talks and the work that I do, my job, at my core, I want to make the lives of developers easier, better, so that you can spend your time writing cool apps and not debugging problems. So I mentioned that I've done a little bit of app work in Beta by Crashlytics, but it's mostly things outside of actual Android apps that my job has really been about. And it's probably, my Android experience is probably limited compared to yours if you are building Android apps today. So my idea for this talk was I'm going to find some tools that people have that I have access to and learn about them and talk about them to you. And so that's what I'm going to do today. So my promise is that you will be able to use the tools in this talk. Right now, you could take out your phone. You can follow along. You don't need a USB cable. You don't need to download new tools. You have them in your pocket right now. So there's the developer options screen inside the Android OS. And it varies a little bit from OS to OS. So newer phones have more things. Older phones might have less or different. But you'll see new things pop up over time. And you've probably turned this on and probably have used 1 or 2, maybe more. My hope is that everyone will learn at least something, even if you're familiar with some of them already. So we dive in, and we take a look, starting at the top. The top option is called Take Bug Report. So if you've ever had a user out in the wild, I hope your apps have users. If you've ever had a user out in the wild to come and tell you, my app is behaving weird, something is wrong, but maybe there's not a crash, so you don't get a crash report, you can have them take a bug report to send the information to you in a way that you can understand, figure out what's happening on the device in the app. So this option gives you 2 choices. You can have an interactive report. So in this case, the user can take screenshots while they're reporting the bug to you and give you some details about what's happening, or just the full report, which collects everything from the device. It takes a few minutes, maybe 5 minutes, to collect all this stuff, and it bundles it up into a giant text file or a zip file if you have pictures, and you can send it off by email. And so you can see the interactive report, the screenshot button. It's really nice. So when you, as the developer, get this report, what is it? It's a massive text file. 200 megs. I mean, it's a big text file with a lot of lines. And so you have to sort of search for the things that are important to you. you might, let's see, we'll take a look at these ones. So these are some of the interesting things that are in the list. A lot of them are just underlying Unix commands from the system. So you can see uptime, how long has the system or the device been running, information about memory statistics, storage, internal storage card, free memory, things like that. CPU info, so just running the top commands. See what's running on the device right now. And then the app activities, services, and providers. This is amazing. The app activity lists out every running app on the device, every fragment of those apps, all of the views. It's like all of the view hierarchy, all of it just written out at the time the bug report was taken. So it's a way for you to see really what's happening, the state of the device. There's also the system log, so that's logcat. When I was trying this out, I had about an hour of logcat sort of scroll back, which is a great amount of time. You can really see what's happened, what's going on in the logcat in that amount of time. So you don't have to ask your users, oh, do you have a USB cable? Can you plug it in? Go to this. Have them take a bug report and send it to you. So the next option is about location mocking. So maybe you've had a user report to you a bug that's only happening in one location. Or you just want to see how your app would behave if it were somewhere else. If this is your first time debugging location problems, this is great for you. If your app is solely based on location, this is probably not enough. It's too simple for you, but you can do a lot with this. So when I first tried this, I was really surprised that I couldn't just put in a latitude and a longitude coordinates. You actually have to select an app which does the location mocking for you. So it comes on when you've picked a debug application or a mock application. So I've downloaded this fake GPS app. It's in the Play Store. Seems OK. And the way that this app ends up in the list is that it defines the access mock location permission in the manifest. And then the way that it does the behavior is by using the set test location provider. So this is how you could write your own mock location app. Or you could get one. Like I said, there are many freely available. If you were using an emulator, it's much easier to mock the location. You can use DDMS or telnet commands. But those are emulator only. So I promised you would have the power in your pocket, and your emulator doesn't fit there. So the next option I want to talk about is wait for debugger. So if you've ever started up your app in debug and you're running into a crash in onCreate, you have to keep attaching it to the debugger every time. If you select a debug application and ask it to wait for the debugger, it will ensure that the debugger has attached already before your onCreate method runs. So this helps you find or fix, locate, target problems that are happening in onCreate of your app in a really nice and easy way. There is a code option, too. You can add a line to wait for debugger. But I promised no extra tools. So it's an option. So have you ever asked a user to send you a send me a video, show me what's happening in the app that you're seeing? Or maybe you want to share the behavior of your app with someone else. If you're looking for funding from someone or looking for a client, you want to send out the app that you've made and get feedback. If you turn on show taps, you're able to see more information about what the user is doing. So I'll show you two videos. The first video on the left, things just start happening out of nowhere. You don't understand what the user is doing to make the app behave that way. So it just starts scrolling. Things are flipping on and off. You don't know why. Or I don't know why it's not happening. There we go. So things are gonna start scrolling around, right? And the one on the right has the show taps turned on. So you can see where the user clicks. You can understand the behavior better and how the app is responding to them. So it might be a little bit more about presentations and less about developer, but it's really nice. So in the next one, we have a pointer location, which is similar to show taps, but it's much more technical. So here, we'll look at another video. Let's see if this works. Great. So you're going to see things start happening, and we'll dive in and figure out exactly what it's doing. OK, so what was all that? So the first thing we saw is the crosshairs. So you can see on screen exactly where the pointer, where the user is touching. You also see this mouse trail, so where the user had touched. This is great because you're able to see if you have gestures or something like that in your app. You can see if it's behaving the way that you expect, because now you see the user input, not just the app output. And diving into that mouse trail, what you see is a different color. So the touch points, as they're registered, are red, and the line drawn between them is blue. So the faster you're moving, the more blue, the fewer touch points in that space over time. And the slower that your finger moves, the more red the line, because the touches are registered much closer together. And the top bar, as the movement is happening, the information up there is changing in display. It's telling you things about the location, how quickly the speed of the movement, how far it's changed over time. So you can really see the details of the user input here. So the next one I want to talk about, it's called Show Layout Bounds. So maybe you've wondered when you're looking at an app where one view starts and the one view ends and the next one starts, wondering about the space, the padding, the margin between them. When you turn this on, you're going to get a lot of colors, a lot of different things start appearing on the screen. But you're able to see in pink the margins of the views, and the blue and red are the bounds. The difference between optical bounds and clip bounds, one is the viewable space, the actual space allocated for the view, and the other includes things like the shadow and other effects. Not super important, the difference between them, but the point is you're able to see the outline, the magical outline drawn where the view would be. So if you have this on, maybe you've also turned on the pointer location. You can see as you're using your app, oh, the touch that I did is not inside the view that I thought it was. So if you're doing some really custom things and it's not behaving, not responding the way that you expect, you can use some of these options together to help you figure out the problem. So new behavior starting in Android O was that objects have a default focus state color. So here, it doesn't translate on the screen, but the OK button on the right has an X over it, and that X is representing the focus state, which element has focus. In O, the color started to be drawn by default for you. It has like a little gray circle. That might conflict with something else that you have going on in your UI. Maybe the color doesn't look quite right, or you want to add your own focus state color. You can use the developer options to see which element has focus presently and if it's rendered the way that you expect. Great. So Android P Preview also added some new things. And you can use developer options to enable functionality that isn't necessarily there on your device. In this case, the functionality that this option enables is adding a cutout, or the notch in the screen, like iPhone X. So you choose the option. Here you have a few different choices. And when it's on, you get the notch. So my device doesn't have that, but I want to test my app in that scenario. I can just go turn it on. So it's cool. In this case, the top bar expands to fit the notch. And you can try your app with all the different possibilities without having to go out and buy new phones that support this. It's pretty cool. So confirming that your app is properly internationalized means a lot of things, translations and layout, many things. But one option that's on the device that is super handy is called force RTL layout, force right to left language layout. And this allows the device to flip the orientation of the layout as if it were in a language that is normally laid out from right to left. I don't speak Persian, Arabic, Hebrew, any languages that are laid out that way. And it's hard for me to use my own app or navigate my device if I've changed the language in order to test. And so you can turn this option on, keep it in your own language that you're able to understand and use your app and device in. But you can see if you've done the layout properly. So you're using start and end padding, not left and right padding. In this case, I actually found a bug when I was taking the screenshots. The debugging header, that should be on the right, and it stayed on the left. And so it looks like somebody might have left in the wrong kind of padding in this case. So I think it's pretty cool. It's a nice way to just give your app a quick try and see how it would look for other users. Like I said, there's a lot more to internationalizing. This is just one way that you can quickly test. OK. So this option for debug GPU overdraw allows you to find hotspots, drawing, places that your app is doing more work than it needs to. So you turn it on. You got all these crazy colors again. But it's telling you about overdraw. And overdraw is when the same pixels, same points on screen, have been drawn over multiple times by different views. So if I have, in this case, the red is the worst. Things have been overdrawn more than 4 times. So there's probably a white screen background, a white background on that section of list view, a white background on the elements. There's no need to draw the white on white on white. Those could have no background, and then they aren't drawn over so many times. And overdraw is a sign of waste, that you're doing work that's unnecessary. So you can turn this on and see if there are places in your app where you could change the layout to have less overdraw. This tool isn't going to help you necessarily dig into exactly which ones. You might need to use something like Hierarchy Viewer to really see the layers in your app, but it's a great way for you to say, very quickly, here's an area I need to target, and use other tools to dig in further. All right. The next thing I want to tell you about is window animation scale. So if you have some custom animations in your app or things in the OS that don't look quite right, you can change the scale, the timing of them, to dive in and take a closer look. So the scale options are from off, no animation, half, that's half the speed, so it's faster, up to 10x. It's 10 times. It's going to take longer. It stretches it out. Let me show you a quick videos about what each looks like. So under normal conditions, maybe your animations look appropriate. But if you speed them up or turn them off, or slow them down or turn them off, you might see some jank or some weird behavior in your app. So the first one is normal. This is how windows come in and out on the OS. This is what we expect. Normal. 10x. This one is excruciatingly slow. Ugh. All right, so you're seeing if there was weird behavior, you'd see it because you have longer to get your eye on it. And the last one, we are not even going to wait for 10x to finish. The last one is off. No animation at all. Just switch to the next view. Quick. All right. I actually, when I was working at Twitter, I was doing a dog food, looking at new versions of Periscope, the app, as it came out. And I had a weird situation where I clicked back, and nothing happened. I couldn't get out of this one screen in the app. Well, it turns out that the developers had bound navigation to the animation finishing. I had animations off, probably for testing something else on my device. There was no animation, so there was no animation finish, so there was no navigation. I just couldn't back out of a specific screen. And nobody could reproduce this, so it works totally fine for us. And I later discovered that it was because of the animations being off on my device. So It's interesting fact. Maybe you don't want to bind navigation to animation finish, or maybe it should have said the animation finished even if it didn't run. I don't know where the bug was, but it was a problem. And there are several types of animations on the device, and they each have their own scale. So window, we already looked at. That's different apps coming in and out. Cool. And I slowed them all down. It's so slow. The next one is transition. This is between different activities in your own app. So maybe you've got some custom animations for transitions here. And the final one, which might not look so great on, yeah, it doesn't translate. Kind of. The tap, the like radiant gray circle from tapping on the tabs at the top, that animation is really slow in this case. So 3 different mechanisms are all scalable with developer options so that you can find the bugs in there. So we'll take our Xray goggles on for a minute and look inside of an app to see behavior that's happening that you can't necessarily see. So this next option, it allows you to see drawing that's happening without drawing that's happening that might not be perceptible. So let's see. In the first case here, this screen is going to do some stuff, right? It's rendering. That's fine. That's it. But then it stops. It's done. It's done its business. That's what you expect. Something changes on screen. It has to draw, and it stops. But if you have a spinner or something for weighting indicator, that's going to keep doing its work. Well, the video stops. But that keeps going. Okay? So in the Beta by Crashlytics app, I had this on, and I noticed there was a rectangle on screen, but there was nothing there. There was no weighting indicator. I'm like, why does it keep flashing pink? It never stops. Well, it turns out that we had one of these little spinners for weighting, and it was there during a transition. And so we faded it out, but we never set it to gone. It was still there animating. Can't see it, but it's doing work. And so the device is doing, or the app was doing much more work than it needed to. It was animating this thing all the time, even though you couldn't see it. So you can put on your Xray goggles and look inside and see things. There's a similar option for looking at hardware layer updates instead of surface updates. So you can see views which are backed by a hardware layer, such as that menu and the keyboard in this case. Just another way, the Xray vision. So here's a really cool option. If you want to understand performance in your app, you can look at the GPU rendering and profile it. So you have the choice to look at it on screen or in ADB. We're definitely going to look at it on the screen. So it looks kind of like this. So you have time as a vertical. So the taller the time, the longer it's spending doing something. And this way is frames. So time per frame. The green line that hopefully you can see here, that's 16 milliseconds. Okay, and that represents the 60 frames per second. So that's like the good speed. You want your performance to generally be lower than that to have fast user perception. So what does it look like? So in this case, I'm scrolling. It's doing work. You expect it to do more work as the app is doing stuff, and it shouldn't be doing things as when nothing's happening. The performance in this app was a little slow. It's because I was debugging, and during debugging it's slower, but you can see that not much of it was below the line. And so there's your bar, your 16 milliseconds bar. So there are a lot of colors, and each of those colors represents a different phase of rendering. You could spend a whole talk diving into what each of these rendering stages is about, but you can look in the documentation to understand individual ones. So turn it on for your app. Figure out what colors. Like, oh, I really need to go look at the orange, some swap buffers, see what's happening, and dive in for how to fix that. So if you have found some of these options that I just talked about useful, in O, the Tiles API became available, and you can allow developer options to be part of your quick settings. So you can go here and turn on which ones you want to see. And then when you swipe down from the top in your quick settings, you can have them right there. So if one of these is your favorite, you want to turn on and turn off layout bounds pretty often, just put it in there, and it's easy to get to. You don't have to go through the system menus, go to the developer options, scroll. There's, I don't know, somewhere 50 different options in the list. Pick the ones as your favorite, put them there, and then you have them at your fingertips all the time. So if you wanted to test the accessibility of your app, there's also a lot of different things that make up accessibility. But I'm going to talk about one option that's available on the device for you to look at. And so this option is called Simulate Color Space. But what it means is simulate color blindness. And if you don't know, there's different types of color blindness. You have blue-green. You have red-green, blue-yellow color blindness. That would you may not be able to see the numbers embedded in here if you are affected by that type of color blindness. And the same way, if you're using color in your app to differentiate between things, if there's nothing else about those views other than color that's different, a user who's colorblind might not see it. So you can simulate the color space for each of these. These are pretty sciencey science names for red, green, and blue, yellow colorblind. But this is what the app would look like once you'd forced it into one of those modes. Something I found interesting about this is that I couldn't take a screenshot of the different color blindness modes because it's not the screenshot's not taken at that layer for whatever reason. So I had to get another phone and hold it above mine to take the screenshots. I thought that was kind of funny. So great. OK. So if you're having problems where your app is crashing and maybe you're not able to reproduce it, you can turn on this thing called Don't Keep Activities, which will kill activities off as soon as their exit, as soon as the user navigates away from them, as if the operating system had killed them for memory. And so you're able to see more problems that users of lower-end devices are running into. And it helps you find more problems in your save and restore instance states methods, which on I have a Pixel 2. I probably don't. These probably don't get exercised very often on my device. Activities aren't often killed. But on devices where memory is more of a factor, they are killed off. And so these get exercised much more often. So you can find your own bugs in here before it gets out to users. And they report back, you have a weird issue, I have a crash. So there you go. Similarly, there's also the option to limit the number of processes running in the background. So if your app has multiple processes, you can turn this on. You can actually have no background processes or limit it to 1 or 2 so that you can see how your app would behave if the process wasn't running. Under normal circumstances, you expect that your main process and your sub-process are running all the time, or you have something for notifications or updating in the background, whatever it is. You expect it to be running. How do you test that it's not running? You can force it to be killed off and see what happens. So my last option for you. Don't be silly like me and take all of your screenshots on different devices at different times of day with different things going on. You can turn on System UI Demo Mode, which will make your title bars all look the same. So those 4 top ones are all from my presentation. They're all different times a day. And the bottom one is what it looks like if you've turned this on. So this is great for taking screenshots for Play or for your website, or just if you're going to do a presentation and you think about it ahead of time, you can force this on so they look nice. And that's all in the developer options. So turn them all on. Enjoy them. I hope that everyone has learned something. I know that there's a lot to digest in here, but I encourage you to take out your own device, turn them on, play with them, and see what happens. And I hope you find bugs so that you can fix them so that your users have a better experience. So thank you. And I'll come down there and take questions in person if anybody has any.